There, okay. Well, we have three variables, right? Probably regret I didn't do this one. Okay, three variables, so we could have, let's call them X, Y, and Z. They could all be free, right? Then you could have let's see, what you could have X be leading, but Y and Z, Y and Z free, right? Because in other words, this is no leading. Then Y could then you could have X leading, Y leading, right? Or you could just have Y leading, but not X leading, right? X and Z free. Okay, so if let's go, so we have sort of two, 1, 2, 3, 4. In case one, where X, Y, and Z are free, what would be the matrix? It would be 0, 0, 0, 0, 0, 0.
Would that be a valid matrix?
Well, it's a valid matrix. I mean, it's in reduced echelon form, right? It just has no leading variables, but every leading variable. So it's like it's not, you're not going to get it from anything else, but it does correspond to equations. It corresponds to your system in the variables X, Y, and Z with two equations, 0 equals 0 and 0 equals 0. So it's sort of a weird trivial equation, right? But it's there. It's one of the reduced echelon form matrices. So that it's the only one of that case. Now, if X is free, that means this is a 1, right? If X is free, this is a 1. There has to be a 0 here. But if Y and Z are free, neither one of them can be leading here. So I have to have zeros there. But then I could have an A and a B. It could have any numbers I want there, right? So this is case 2, where this is X leading and Y and Z are free. So I think this captures all the possible ones there, right? Then this is like case 1. This is case 2. And then case 3 would be X leading and Y leading. Well, X would have to be leading here. Y would have to be leading here. That would have to be 0 to be in echelon form. And then this could be A and B. They could be any numbers here. This is the case X leading and Y leading. So X has to be here, 0 there. Y has to be here leading, 0 there. So this is the case 3. And A and B could be 0 here, right? But they could be any other numbers. Okay, so there's 3. How about 4? Y leading, but X and Z free. Well, so X can't be leading, so it has to be that Y is the leading number in the first row. And then so it has to start off like that if I want Y leading and X and Z free. So I can't have a 1 here because that would make Z free. So here's the one for case 4. However, this was not quite what you expected. It's probably easier with 2x2 matrices, but this shows how. But still, there's only sort of a fixed number. You can sort of like sort out what the different possibilities are. Did you have Z leading? Oh, what if? Oh yes, no, I left off one. Yes, as someone pointed out. In fact, there's several more. Okay, 5. we can have Y and Z leading. And 6, Z leading. Okay, so there are some more. Okay, so 5, let's have Y and Z leading. Okay, well, that would be 0, 1, Y is leading, 0, 0, 1, 0. Okay, this is 5, Y and Z leading, right? I think there's only one matrix to that form. Because if Y is leading and Z is leading, everything else has to be zeros. And X is free. Okay, and then Z can be leading, right? Oh, there's that matrix. Yeah, there's this one. Okay, so even more. Let's see. We have X leading, Y leading, Z leading, then any of the other 2 leading. Anyone else see any other ones? Okay, well, there's the, let me see, X, do we have X and Z leading? Oh, let's see, what would that look like? X and Z leading. Maybe we don't have that. X. Yeah, this would have to be, yes, we don't. This is X and Z leading. So I had to be more systematic. You could have X leading, you could have one variable leading, X, Y, or Z. You could have any 2 leading, X, Y, X, Z, or Y, Z. Okay, well, fun with reduced to echelon form matrices, right?